All right. Hi, everybody. Thanks for coming. I really appreciate it, especially because I know we are getting towards the end of the conference. So I really, really appreciate that so many of you decided to join my talk. So far, I talked to probably many of you. I had really interesting discussions with many of you over at the ScyllaDB booth. So hopefully my talk will be very interesting and relevant for many of you. Let's get started. Before I actually start, I just wanted to ask a quick question, which is by show of hands, how many of you had experienced database performance issues while working on an application, and maybe the database was slow, maybe the query execution time took forever? So most of you, which is great. I mean, it's not great when you are experiencing the issue, but it's great because then this talk might be really relevant for many of you. And another quick question, how many of you used some kind of a cache solution to try to solve this problem? All right, many of you, somehow even more people, so that's interesting. So that's great because this talk will be relevant for many of you. So let's get started. So just a little bit about me. So I'm Attila Tóth. I'm with ScyllaDB. As I mentioned, we have a booth here, and I've been working as a software engineer or a developer advocate in the data space for more than 6 years now. And I live in Budapest, Hungary. So that's about me. So this is what we're going to cover today. I only have 25 minutes, so I'm happy to continue this conversation afterwards. We can go deeper. So first I'm going to cover low latency and what we mean when we say low latency. At ScyllaDB, we talk a lot about low latency. Then I'm going to talk about cache and caching as a possible solution to your latency problems. I'm going to talk about different caching strategies. Then I'm going to cover what some problems you might encounter if you use an external caching solution. And then finally, I will talk about ScyllaDB and when and why you might consider that as a way to replace your cache. All right, so why does low latency matter? So before that, maybe it's useful to just step back a little bit and talk about latency. What do I mean by latency, and specifically database latency, because that's kind of the topic for today. So just a very simple definition. Latency is the time needed for the database to receive a request, process the transaction, and then respond correctly. So basically, you might make a query to the database. The database needs some time to process that query and then return data or return some form of a response. And latency is used to measure the time it takes for the database to do that. It's a very useful tool to diagnose problems. So you might have an application, a mobile application, or some kind of an application where users report issues with slowness, or the app is being unresponsive. And then you might want to look at your cache dashboards or your different database monitoring tools to diagnose the problems. And latency might be one of the main metrics that you look at. Generally, we measure latency in milliseconds, especially if you are building some form of a real-time application where you really want your data to be as real-time as possible. Then, when it comes to different associations, usually low latency is associated with positive user experience. So if an app works properly and the user doesn't need to wait for things to happen and everything is fast, obviously people like that. That's what people often expect. And then on the other hand, if you have high latency in the database or somewhere or in some other place in your system, that is associated with poor user experience. So obviously people do not like that. Now, why does low latency matter from a business perspective? And I just pulled here a couple of researches and some numbers to try to prove that latency does matter on the business end as well, especially on the business side of things. So for example, Walmart did a research where they found that for every 1 second improvement in page load time, conversions actually increased by 2%, which doesn't sound like a lot, like 2% doesn't seem much, but if you use the same numbers for some other business where, let's say, the sales was 10 million per year, then a 2% increase in conversions could mean $200,000 in increase, which I think can be considered significant. Another research from Cloudflare says that if an e-commerce site loads within a second, so if the delay is less than a second, that converts 150% more visitors than another site that loads in 5 seconds. So obviously that is a huge difference, especially if you consider that it's just a few second difference in delay, but the conversion is just so much higher. So latency definitely produces more conversions. And then I just wanted to pull in an example from one of our customers. Attila Grab. Grab is a transportation company. They do like taxi services. They do things like food delivery. So they have a lot of ride requests on their app, through their app, more than 6 million a day. And so obviously, if you have a large-scale app like that, low latency is super important because you can lose out on a significant amount of revenue if you have high latency. So just to summarize, why does low latency matter? Low latency means faster responses. Ultimately, it will lead to happier users, happier customers, and that can lead to high revenue at the end of the day. All right, so let's get a little bit more specific on the latency side. How we measure latency and why tail latency especially is really important. So first of all, what is tail latency, or you can call it long tail latency? So if you're not super familiar with latency, we usually measure it in using percentiles. So, for example, the 50th percentile is the median latency, which means that if the 50th percentile is, let's say, 10 milliseconds, then 50% of the requests are actually will experience higher latency than 10 milliseconds. Or if the 99th percentile is 10 milliseconds, that means that only 1% of all the requests will experience a higher latency. We commonly refer to these percentile measurements using P50, P90, P95, P99. So you often see these measurements in articles and papers where they refer to latency using something like P99. All right, and long tail latency, so everything, so P99 and everything above that is considered a measurement of long tail latency. And P99 is probably one of the main metrics that we use to track latency, which might sound interesting because P99, as I mentioned, it means that only 1% of the requests have a higher latency. Why do we care about that 1%? Like, why is that super important? It's just 1%. And so I bring a really simple high-level example here, why that 1% really matters. So let's say we have a user. Has some app. They interact with the app. They hit refresh, or they click a button, or they do something to interact with the application itself. Then on the front-end side, this will generate probably multiple API calls. There is probably some business logic on the backend side, and there is probably some function on the backend side that will call multiple, create multiple database queries. So basically, the database will receive multiple queries, even for just a single user interaction. And if you have a large-scale application where you have a lot of users doing a lot of different things at the same time, this can have this can generate a lot of database calls. And what ends up happening is that and yes, everything is all the database calls are towards the database, of course. And what can end up happening is that the slowest 1% of the request will dominate the latency. So those 1% requests, the slowest ones, will overwhelm the database, and this could have kind of a cascading effect on the database, and ultimately your overall database latency can significantly get increased. So that's why tail latency is very important. I forgot to start my timer, so if you guys can remind me when I'm nearing towards the end, that would be great. Let's talk about solving latency problems with cache. Because a lot of times people, when they encounter these problems, they recognize the need for a cache, so they start to look for a solution. But first, let's look at a very simple, again, very high-level example, what it looks like without a cache. So again, we have let's say a mobile app. We have a database, and then let's say it takes 50 milliseconds to get to the database, or more than 50 milliseconds. Then the database itself will take, again, more than 50 milliseconds to actually execute the query. And then because, again, it will need to go back to the application itself, overall, it adds up to more than 150 milliseconds. Now, let's say this is not good enough for us. This is a requirement. We have a requirement that says it needs to be faster. So let's introduce a cache. So with cache, we still have the application. Now we have this other player in the stack, which is an external cache. And now this is great because with the cache, the latency is now down to less than a millisecond. On the other side, if we have a cache miss, or for some reason we cannot get the data from the cache because it's not populated yet, then we still need to go back to the database. In that case, we still experience a higher latency. But that is the very basic idea, a very simple illustration of using an external cache. And yes, the database still needs more than 50 milliseconds to execute the query. So in this scenario, we still might not meet requirements. Now let's look at some caching strategies. So the most simplistic one is when you have a cache implemented inside the application, and you store a little portion of your database inside your app, and that's and it's very close to your code. That is the most simple sort of cache. Then you can have a cache put in front of your database, and all of your database requests go through this layer. Now, an example for this would be if you use something like DynamoDB, and DynamoDB has a DynamoDB accelerator, which is kind of a transparent cache because you can the API is the same, and you can go through this layer, and you will use a cache layer. Now, there could be problems here if you, for some reason, you end up writing directly to DynamoDB. That could cause problems. So you are suggested to always go through DAX if you use DAX. But obviously, if you are doing that, it's going to cost you more money because you are going through DAX. Another strategy is the write around or write back strategy, where you actually have an external cache sitting on the side, and normally you want to get the data from this external cache. And if you do, just like showed in the previous image, you get really low latency. And in cases where you cannot get data from the cache, you have to do a round trip going to the database, which will increase the latency. An example for this would be if you are using Cassandra, but you're not happy with the latency that Cassandra provides, or maybe it's not stable enough for you, then you implement something like Redis as an external cache to meet latency requirements. Then the final strategy is what we use at ScyllaDB, which is the embedded read-through strategy, where you basically have a cache implemented internally, embedded in the database, and you don't have to configure it, you don't have to really think about it. It just works under the hood, and you can just use your main database and make use of the internal caching mechanism to meet latency requirements. All right, now let's talk about the problems when it comes to external caching solutions. So one of the main problems is that even though the goal is to reduce latency, you want to do things faster, what might end up happening is that you increase latency because you often need to go back to the main database if the cache is not populated, and sometimes people experience a cache miss. A cache miss is when you cannot get the data from, for example, Redis, because it's not in sync with the database yet. So what you might expect that you will have just a few amount of cache misses, but in reality might get a lot more than you expected, and in that way you will end up just going back to the main database, and you will have much higher latencies that you wanted. So that is the first or one of the problems. Another problem is obviously elevated costs, because now you have not just one system that you have to maintain, but two. And also, if your application grows, you have more users, more requests, you will have to scale up, and now you cannot just scale up the main database, you also need to scale up your, let's say, Redis cluster, and it's going to cost you more money in terms of maintenance, but also in terms of just actual costs. For example, if you are running everything in the cloud, it's going to cost you more money. And there are much more. Actually, I have some listed here, but there are a lot more things that could be mentioned here. What I would mention today is probably the last one, which is actually for some people might say that this is like the biggest disadvantage of an external cache, which is it ruins your database's own cache solution and optimization. And I would add to that also, like generally, not just with ScyllaDB, but any database, usually they are gathering a lot of metadata to kind of understand your query patterns and how you are querying the database. And if you're using a cache layer, then you are going to want to query the cache, not your main database. And so your main database will not have that kind of metadata information that it needs to really optimize and make it faster for you to execute the queries. So that is a big disadvantage. And I probably mentioned the overall application complexity as well, because now you have multiple systems to maintain. And then there could be differences between the external cache and the database in terms of how data is stored. For example, ScyllaDB is a key value store, and if your cache is a key value store, then you probably have to change the schema, or if you are using some special data type in your database that is not available in your cache, then you have to figure out a solution for that as well. So there are some disadvantages with this approach. All right, now quickly I will talk about ScyllaDB as a possible cache replacement. So just real quick, I'm not going to list everything here, but if you're not familiar with ScyllaDB, it's a low latency NoSQL database for a data intensive application. We have a very close to the metal architecture, We are compatible with Apache Cassandra and DynamoDB, so it's very easy to migrate from those systems. We have a cloud solution, but we are also available in an open source capacity, so you can try ScyllaDB for free and play with it if you want to. We have a lot of companies that use us. The biggest and most popular one, at least recently, is probably Discord. They migrated from Cassandra to store their messages, but we also have Epic Games and some other big companies in our portfolio. Now, a little bit about the architecture of ScyllaDB. As I mentioned, it's a key value store. Now, many of you are probably familiar with key value stores. This is similar, except we have 2 keys, not just one. So what that means is that the first key is used to partition the table. So for example, this could be an ID, some kind of a unique identifier. The second key is used to sort within the cluster. We call it a clustering key, but you can also call it a sorting key. And basically, the idea is that this way you can query data not just by the main query, the ID, but you can also, in this example, add the timestamp column as a clustering key. So you will have you can write queries where you have the ID and the time range filter, and those queries will be really fast. But it really depends on your application, how you want to model your data. But this is how ScyllaDB stores data. All right, so I'm not going to list everything here because we don't have time, but ScyllaDB is built in C++, so we don't have the kind of issues that are associated with Java-based systems, like garbage collection. We have a shared nothing architecture. So what that means is that, as you can see in the nodes, we have a kind of a ring architecture, and the nodes don't share any resources between them. And we also have a specialized cache, as I mentioned, an embedded cache. And ultimately, everything together adding up to a system where ScyllaDB is enabled to scale up and provide really good performance for for workloads where you need low latency and you have a lot of data. So a little bit about our cache-specific features and cache-related things. So this is just a screenshot from ScyllaDB monitoring, which is a set of dashboards and tools to monitor your ScyllaDB instances. You can monitor cache-related things like cache hits, misses, all the latency measurements that you care about. Then one interesting feature is you can enable or disable caching per table. So for example, if you have a table where you think that you don't actually need cache because you are running a different workload and you don't want to use cache, you can do that. As I mentioned, we are Apache Cassandra compatible, so we use the CQL, the Cassandra query language. And then on top of that, we add a few extensions, so extra CQL commands that you can use. One of these is the bypass cache one, which basically makes it easy for you to if you run a query where you don't want to cache that specific query, then you can just add bypass cache to your command, and that way it's not going to get cached. So it might be useful in some cases. All right, and just quickly, some cache-related success stories. So we have Disney Plus Hotstar as a customer, and they switched from Redis plus Elasticsearch to ScyllaDB because ScyllaDB was able to provide the kind of performance that an in-memory database can provide, which in this example means less than 1 millisecond P99 latency. Overall, they reduced costs and they achieved zero downtime. Another quick example is a company I mentioned already, Grab. They used an external cache, Redis again, and they switched to ScyllaDB. They were able to achieve the speed of Redis, but with higher scalability, lower costs. And yeah, that's all I wanted to say. So thank you very much. I will be here until the end of the event. So I will be happy to continue discussing cache and other topics with you later. And make sure to come by the ScyllaDB booth if you haven't already. Thank you.